day to everyone. I welcome you all in my YouTube video channel. Today I will deliver lecture on trigonometry degree level chapter complex arguments, lecture number 6, in which I will solve some more problems on logarithms of complex quantities. Now we solve a problem. Problem is, if a1 plus ib1 multiply a2 plus ib2 multiply dot 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 an plus ibn equal to capital A plus I capital B. Prove that number 1, tan inverse b1 by a1 plus tan inverse b2 by a2 plus dot 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 plus tan inverse bn by an equal to tan inverse capital B by capital A. Number 2, a1 square plus b1 square multiply a2 square plus b2 square multiply dot 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 an square plus bn square equal to capital A square plus capital B square. Now we solve this. Solution. Since given that a1 plus ib1 multiply a2 plus ib2 multiply an plus ibn equal to capital A plus I capital B. Applying logarithm in both sides, we get log a1 plus ib1 multiply a2 plus ib2 multiply an plus ibn equal to log capital A plus I capital B. Implies that log m into n multiply this equal to log m plus log n plus dot 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 dot. This is log a1 plus ib1 plus log a2 plus ib2 plus dot 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 plus log an plus ibn, and this is equal to log capital A plus I capital B. Implies that log a1 plus ib1 equal to half log a1 square plus b1 square plus I tan inverse b1 by a1 plus log a2 plus ib2 equal to half log a2 square plus b2 square plus I tan inverse b2 by a2 plus dot 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 plus log an plus ibn equal to half log an square plus bn square plus I tan inverse bn by an, and this is equal to here log capital A plus I capital B. This is equal to half log capital A square plus capital B square plus I tan inverse capital B by capital A equating real and imaginary parts of both sides. We get, firstly we equate imaginary parts. This is imaginary part, this is imaginary part, left side, these are imaginary parts. Tan inverse B1 by A1 plus tan inverse B2 by A2 plus dot 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 plus tan inverse Bn by An. In right side, imaginary part is tan inverse capital B by capital A. So, therefore, number 1 proved. Now, equating real parts of both sides. And half we take common, equating real parts. Half, here half, log A1 square plus B1 square plus log A2 square plus B2 square plus dot 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 plus log An square plus Bn square equal to right side half log capital A square plus capital B square. Implies that half cancel both sides and log A plus log n plus dot 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 equal to log n multiply dot 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 A1 square plus B1 square multiply A2 square plus B2 square multiply dot 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 An square plus Bn square equal to log capital A square plus capital B square. Implies that removing log from both sides, A1 square plus B1 square multiply A2 square plus B2 square multiply dot 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 An square plus Bn square equal to capital A square plus capital B square. And this is number 2 proved. Number 2 proved. Now we solve the next problem. Next problem is if tan log alpha plus I beta equal to x plus iy, where x square plus y square is not equal to 1, prove that tan log alpha square plus beta square equal to 2x by 1 minus x square minus y square. Now we solve this. Given that tan log alpha plus I beta equal to x plus iy, implies that log alpha plus I beta equal to tan inverse x plus iy. This is number 1. Implies that log alpha minus I beta equal to tan inverse x minus iy. This is number 2. Since log alpha square plus beta square equal to log alpha plus I beta multiply alpha minus I beta, and this is equal to log m multiply n equal to log m plus log n. Log alpha plus I beta plus log alpha minus I beta. Here log alpha plus I beta equal to tan inverse x plus iy. We write tan inverse x plus iy plus here log alpha minus I beta is tan inverse x minus iy. Tan inverse x minus iy implies that log alpha square plus beta square equal to tan inverse x plus tan inverse y is tan inverse x plus y by 1 minus xy. This is tan inverse first x plus iy plus x minus iy by 1 minus x plus iy multiply x minus iy. This is equal to tan inverse iy plus iy minus cancel remains 2x by 1 minus x plus iy multiply x minus iy is x square plus y square. This is number 3. Since given that x square plus y square is not equal to 1, therefore right side of 3 is valid, because 1 minus x square plus y square not equal to 0. Therefore, 3 may be written as log alpha square plus beta square equal to tan inverse 2x by 1 minus x square minus y square. Proved. Now we solve the next problem. Next problem is so that 10 under bracket I log a minus ib by a plus ib bracket closed equal to 2ab by a square minus b square. Now we solve this. Let a equal to r cos theta, this is number 1, b equal to r sin theta, this is number 2. Now log a minus ib by a plus ib equal to log a means r cos theta minus ib means r sin theta. Here a means r cos theta plus ib means r sin theta, and this is equal to log r common cos theta minus I sin theta by r common cos theta plus I sin theta. R cancel. Here cos theta minus I sin theta is e to the power minus I theta by cos theta plus I sin theta is e to the power I theta, and this will be equal to log e to the power minus I theta and minus I theta. This is equal to log e to the power minus 2I theta, and this is equal to minus 2I theta log base E principal value, and this is equal to minus 2I theta multiply 1. This is equal to minus 2I theta. This is number 3. From 1 and 2, B by A equal to R sin theta by R cos theta implies that B by A equal to R cancel tan theta, implies that theta equal to tan inverse B by A. This is number 4. Using 4 in theory, we get log A minus IB by A plus IB equal to minus 2I theta equal to tan inverse B by A, implies that multiplying both sides by I log A minus IB by A plus IB equal to minus 2 I multiply I tan inverse B by A, implies that I log A minus IB by A plus IB. Here I square is minus 1. So minus minus plus 2 tan inverse B by A. Since I square equal to minus 1, implies that I log A minus IB by A plus IB equal to 2 tan inverse B by A is tan 2 B by A by 1 minus B square by A square, and this is equal to tan inverse 2 B by A multiply A square by A square minus B square, and this is equal to tan inverse A cancel 2AB by A square minus B square, implies that tan I log A minus IB by A plus IB equal to 2AB by A square minus B square. Here we have tan inverse, and we take this left side, then left side will become tan, and right side, in right side we get only 2AB by A square minus B square. Therefore proved. Thanks for watching my video. If you are satisfied with my presentation and contents, then please click on like button and do subscribe my YouTube channel. Thank you.